The jet that has defined American carrier aviation for 30 years is dying. Not in combat, not from enemy fire. From age, from physics, and from a deliberate decision by the United States Navy to replace it with something that costs 3 times as much, requires entirely different infrastructure, and is still being delivered years behind schedule. The F-18 Super Hornet. VFA squadrons from Oceana to Lemoore. The aircraft that flew Desert Storm, that fought over Iraq and Afghanistan and Syria, that launched strikes against Iranian targets in Operation Epic Fury from the decks of the Abraham Lincoln and the Gerald R. Ford. The final order for new Super Hornets was placed in 2024, valued at $1.1 billion. Boeing's production line in St. Louis, where every Super Hornet ever built rolled off the assembly floor, is being shut down. The last jets are expected to leave the line in 2027. After that, the most capable fourth-generation naval fighter in history will no longer be manufactured. The ones that exist will be flown until they run out of airframe life, and then they will go to the boneyard. Why is the Navy doing this? Why retire a proven, upgraded, combat-effective aircraft that is currently flying combat missions right now in favor of a replacement program that is delayed, over budget, and technically incomplete? And what does the transition from the Super Hornet to the F-35C mean for the actual combat capability of American carrier air wings in the decade ahead? This is the full story of the F-18's retirement, the F-35C transition that is replacing it, the F/A-XX sixth-generation program that is supposed to come after that, and why the gap between retiring the old and fielding the new is creating a capability cliff that has serious people in the Pentagon genuinely worried. The Super Hornet story begins in the late 1970s, when McDonnell Douglas and Northrop were competing to replace the Navy's aging A-7 Corsair and F-14 Tomcat. The original F/A-18 Hornet that emerged from that competition was a smaller, lighter jet optimized for both air-to-air and air-to-ground missions, hence the dual designation, the slash between the F and the A. It entered service in 1983. It flew its first combat missions over Lebanon that same year. It went on to fight in Libya in 1986, in the Persian Gulf in 1991, over Iraq through the entire duration of Operation Iraqi Freedom and Operation Enduring Freedom, over Syria and Iraq in the campaign against ISIS, and most recently over Iran in 2025 and 2026. 43 years of continuous combat relevance is an extraordinary record for any weapons system. The F/A-18 E/F Super Hornet that began replacing the original Hornet in the late 1990s was not simply an upgrade. It was a substantially new aircraft that happened to share the same name and basic configuration. The airframe is 30% larger than the original. The engines are completely different. General Electric F414s replacing the original F404s, providing significantly more thrust. The avionics are entirely different. The radar, initially the APG-73 and later the APG-79 Active Electronically Scanned Array, represents a generational improvement in sensor capability over what the original Hornet carried. Conformal fuel tanks were added to extend range and reduce the radar cross-section. New weapon systems, including the AIM-120DAMR-AAM, the AGM-154 Joint Standoff Weapon, and the AGM-158CLR-ASM Long-Range Anti-Ship Missile, were integrated into the Air Wing Strike Package. The Super Hornet that is flying combat missions over Iran today is functionally a different aircraft from the one that entered production in 1995. But here is the problem that no amount of upgrading can solve. The Super Hornet is not stealthy. Its basic configuration, its inlet geometry, its wing shape, its external weapons pylons, All of these features produce a radar cross-section that is detectable by modern air defense radars at ranges that give opposing surface-to-air missile systems ample time to fire. Conformal fuel tanks and carefully designed external stores pods reduce that signature somewhat. They do not eliminate it. In an environment where Russian and Chinese very high-frequency radar systems, the NEBO-M, the Resonance NE, and the Chinese JY-27A, can potentially detect even the F-35's reduced radar cross-section at certain aspects and ranges, a Super Hornet is not surviving the first pass over a modern integrated air defense system that has not been suppressed in advance. In the Iranian campaign, this limitation has not been decisive because American cyber and electronic warfare operations degraded Iranian air defenses before the Super Hornets flew their first combat missions. The EA-18G Growlers went first, the cyber operations went first, the Tomahawks went first. By the time Super Hornets were flying strike missions over Iranian targets, the air defense environment had been reduced to a level where the aircraft's lack of stealth was not a fatal vulnerability. In a Taiwan scenario against China's genuinely formidable integrated air defense system, that sequence of events would be far more difficult to execute. China's air defense architecture is deeper, more redundant, more modern, and better integrated than anything Iran possessed. Against China, the Super Hornet's survivability in a contested environment is a genuine concern that no upgrade program can fully address. This is the fundamental argument for the transition to the F-35C. The F-35C's low observable airframe, with its carefully shaped surfaces, its internal weapons bays that eliminate the radar return of external pylons, and its radar-absorbent material coatings, achieves a level of signature reduction that the Super Hornet's physical configuration makes impossible to replicate. Against modern air defense radars operating at X-band frequencies, the F-35C presents a radar cross-section that is orders of magnitude smaller than the Super Hornet. This is not a marginal improvement. It is a qualitative difference that determines whether an aircraft can survive in the most contested airspace on Earth without dedicated suppression support. The F-35C also carries capabilities that no Super Hornet can match, regardless of how extensively it is upgraded. The AN/APG-81 AESA radar is significantly more capable than the Super Hornet's APG-79. The distributed aperture system, 6 infrared cameras providing spherical situational awareness around the aircraft, has no equivalent on any fourth-generation fighter. The electro-optical targeting system integrated into the aircraft's nose provides capabilities that would require an external pod on a Super Hornet, restoring the radar cross-section penalty that the F-35's internal carriage eliminates, and the sensor fusion that integrates data from all of these systems into a single display for the pilot, presenting a synthesized picture of the battle space rather than a collection of individual sensor feeds, represents a qualitative leap in pilot situational awareness that translates directly into tactical effectiveness. These capabilities are not theoretical. The F-35C's combat debut came with the Carrier Air Wing 2 deployment aboard the USS Carl Vinson in 2022, followed by subsequent deployments that have included combat operations in the Middle East. The Abraham Lincoln's F-35Cs, flying in support of Operation Epic Fury right now, are demonstrating the aircraft's combat effectiveness in real operational conditions. An F-35C from the Abraham Lincoln shot down an Iranian drone on February 3, 2026, before Epic Fury officially began, demonstrating the aircraft's air-to-air capability in the actual operational environment. The transition from Super Hornet to F-35C is not a leap of faith. It is a transition to a system with demonstrated combat capability. But the transition is not without its costs and its complications. The most immediate complication is the airframe life problem. The Congressional Budget Office assessed in 2023 that Super Hornets are deteriorating at a faster rate than the original F/A-18 Hornets that preceded them in service. The Service Life Extension Program, SLEP, was designed to extend the Super Hornet's service life to 9,000 hours, sufficient to keep the aircraft relevant through the early 2030s, when the F/A-XX sixth-generation replacement was originally projected to arrive. But the SLEP faces a fundamental physical limit. There is only so much stress cycling an aluminum alloy airframe can absorb before the metal fatigue that accumulates in every flight hour reaches the point where structural integrity cannot be guaranteed. The SLEP modifies the airframe, replaces components, and extends the maintenance intervals that determine when a jet must be retired. It cannot reverse the cumulative fatigue of decades of flight operations, carrier landings, catapult launches, and the routine violence that naval aviation imposes on every aircraft in the fleet. The production line closing in 2027 means that when Super Hornets reach the end of their extended service life in the early to mid-2030s, they cannot be replaced with new production aircraft. The inventory that exists when the line closes is the inventory the Navy has to work with. If those aircraft are consumed by combat losses, by accidents, by accelerated fatigue from high operational tempo, or by the simple arithmetic of years of carrier operations, there are no more coming. The Navy's ability to sustain Super Hornet numbers through the transition period to full F-35C fielding depends entirely on the aircraft it has right now, lasting as long as the program assumes they will. The F-35C transition creates its own set of complications that go beyond the aircraft itself. Transitioning a carrier air wing from Super Hornets to F-35Cs requires modifying the ship's infrastructure to support the F-35's unique maintenance requirements, as we discussed in the context of the USS Gerald R. Ford. But even for Nimitz-class carriers that have already made those modifications, the transition involves a learning curve at the squadron level that affects operational readiness in the near term. F-35C pilots require different training than Super Hornet pilots, not because the jet is harder to fly. In many respects, the F-35's avionics automation makes it more manageable than the Super Hornet in the cockpit, but because exploiting the jet's full capability requires a different tactical mindset, a different approach to mission planning, and a different understanding of how sensor fusion and networked operations change the way a carrier air wing fights. The maintenance profile of the F-35C is also substantially different from the Super Hornet, and not in ways that make the maintainer's job easier. The low observable coatings that give the F-35 its stealth characteristics require careful treatment. The climate-controlled facilities needed to apply and repair those coatings are not present on every carrier. The Autonomic Logistics Information System that manages F-35 maintenance requires specific hardware and network infrastructure. The specialized test benches and tooling for the F-35's unique systems require training and equipment that the Super Hornet's maintainers did not need. In the near term, the Navy is operating a mixed fleet of Super Hornets and F-35Cs that requires expertise in both maintenance ecosystems simultaneously, creating a training and manning burden that the service is managing, but that will not fully resolve until the Super Hornet is fully retired. Then there is the F/A-XX problem, and this is where the Navy's aviation future faces its most serious challenge. The F/A-XX is the sixth-generation fighter that was supposed to replace the Super Hornet in the 2030s, complementing the F-35C and providing the carrier air wing with a capability that could operate in the threat environment that China's military will present by the 2030s and beyond. In March 2025, Lockheed Martin was eliminated from the F/A-XX competition, leaving Boeing and Northrop Grumman as the remaining competitors. In July 2025, Congress approved just $76 million in funding for the F/A-XX program for fiscal year 2026. $76 million. against a program that requires billions in annual investment to develop a sixth-generation aircraft on any timeline that would actually deliver the capability. Before the Super Hornets it is supposed to replace have all reached the end of their service lives. For comparison, the Air Force's F-47N GAD program received $3.4 billion in the same budget cycle. The disparity is stark. The Air Force is receiving more than 44 times as much funding for its sixth-generation fighter program as the Navy is receiving for its equivalent. The 1945 analysis described the F/A-XX as being on life support, and that characterization is difficult to dispute when the program is receiving $76 million against a development requirement that industry estimates in the tens of billions over the full development cycle. Congress has effectively made a decision about priorities that will shape the character of carrier aviation for decades. And that decision is that the Air Force's land-based sixth-generation capability will be developed and fielded while the Navy's carrier-based equivalent is delayed, potentially for years, while Super Hornets reach the end of their service lives and F-35Cs confront an evolving threat environment without the successor platform they were supposed to be complemented by. The Chinese context makes this funding disparity alarming in ways that go beyond simple budget math. China is actively flight testing the J-36, a sixth-generation aircraft with a tailless flying wing configuration that suggests genuine stealth capability and potentially supercruise performance. The J-35 fifth-generation fighter, already launching from the Fujian's electromagnetic catapult, gives the plan a carrier-based stealth capability that it is already deploying operationally. If the F/A-XX program continues to receive funding at the $76 million level, the United States Navy faces a scenario in the late 2030s where Chinese carrier air wings are flying sixth-generation fighters, while American carrier air wings are flying F-35Cs that have been in service for 20-plus years against threat systems specifically designed to defeat them. The F-35C itself is not standing still. Block 4 upgrades incorporating technology, Refresh 3 hardware and the associated software enhancements are designed to expand the aircraft's weapons capacity, improve its electronic warfare systems, and enhance its networking capability. But TR-3 has been plagued by software instability that has delayed deliveries and created a backlog of F-35s awaiting the upgrade. The F-35 Joint Program Office has been managing this delay, and deliveries are expected to normalize. But the delay has real consequences for the Navy's transition timeline and for the readiness of air wings that are waiting for upgraded aircraft. The broader picture of American carrier aviation in 2026 is one of genuine capability combined with genuine uncertainty about the future. The F-35C is demonstrating real combat effectiveness in the Iranian theater. The Super Hornet is performing its transition period mission with the effectiveness that 40 years of refinement have produced. The Navy's carrier air wings are the most capable they have ever been in terms of the average capability of the aircraft they fly. But the production line for the Super Hornet is closing. The F/A-XX is on life support. The F-35C Block 4 is delayed. And China is fielding sixth-generation aircraft while the Navy's equivalent program is funded at a level that cannot sustain competitive development. The transition from Super Hornet to F-35C is the right decision. The logic is compelling, and the operational results are validating it. But the gap between closing one production line and fully fielding its replacement, compounded by the underfunding of the program that is supposed to come after the replacement, creates a trajectory for carrier aviation that requires more investment and more urgency than the current budget reflects. The Super Hornet flew its last combat mission over Lebanese skies in 1983. 43 years later, it is flying combat missions over Iran. It has outlasted its own planned retirement multiple times. It has been upgraded, extended, modified, and kept relevant through an extraordinary program of continuous improvement. But there are limits to how long any aircraft design can remain at the cutting edge of a threat environment that is advancing faster than the upgrade programs can follow. The Navy is killing its F-18 fleet. The decision is correct. The question is whether the replacement is being funded and fielded on a timeline that the threat environment will wait for. China is not waiting. If you want to understand the full picture of where carrier aviation is heading, what the F/A-XX funding crisis means for the long-term balance of power at sea, and how the transition to an all-fifth-generation carrier air wing changes the way the Navy fights, subscribe to Navy Power Decoded. Every week we go deeper than the headlines. The Super Hornet's final chapter is being written over Iran right now. Make sure you understand what comes next. There is one more dimension to the Super Hornet retirement story that rarely gets the attention it deserves, and it is the industrial-based dimension. When Boeing closes its F/A-18 production line in St. Louis in 2027, it is not just ending a production program. It is dismantling a manufacturing capability that took decades to build and that cannot be quickly reconstituted if circumstances change. The skilled machinists who build Super Hornets are already retiring faster than they can be replaced. The Boeing strike by IAM Local 837 in 2025, which entered its 9th week before resolution, highlighted the fragility of the workforce that sustains these production lines. The tooling, the supply chain, the specialized manufacturing processes for the Super Hornet's specific materials and configurations, all of it disperses when the line closes. The 350 local suppliers that depend on Boeing's St. Louis operations for a combined $750 million in annual revenue will redirect their capacity to other products. The 16,000 direct Boeing employees and 34,000 indirect jobs that support the Super Hornet production ecosystem will transition to other work. If the Navy ever needed to restart Super Hornet production, perhaps because the F-35C program encountered a catastrophic problem, perhaps because the F/A-XX was delayed beyond the point where Super Hornets could bridge the gap, perhaps because combat losses in a high-intensity conflict consumed the inventory faster than anticipated, the industrial base to do it would not exist. The restart costs and timeline for a closed production line are measured in years and billions of dollars. This is not a theoretical concern. The history of American defense acquisition is full of programs that were canceled, production lines that were shut down, and capabilities that could not be reconstituted when the strategic situation changed and the capability was urgently needed again. The Navy is making a deliberate bet that the F-35C transition will succeed on its current timeline, that the F/A-XX will eventually receive adequate funding and will deliver a 6th-generation capability before the gap between retiring Super Hornets and fielding their replacement becomes operationally critical, and that combat losses in any near-term conflict will not exceed the inventory that the closed production line leaves behind. That bet may prove correct. The F-35C is performing. The transition is progressing. The threat environment may not materialize on the timeline that the most pessimistic analysts project, but the Super Hornet's retirement is irreversible once the line closes. The Navy is betting its carrier aviation future on programs that are delayed, underfunded, or both. And the adversary those programs are designed to address is not waiting for American timelines to be met. The last Super Hornet will roll off the line in 2027. The line will close, and what comes next will define American sea power for a generation.